Today, we continue to work on our typing trainer. And so far, what we have is a nice UI and input handling, which allows us to practice our typing skills. The problem, the major or the main problem right now is that this text that we have is always the same. So if you remember, we have this hard-coded text, and we have a nice to-do saying here, like let's grab text from different sources. So by the end of this video, what we would like to do is to be able to grab text the same way, the hard-coded one. We would like to be able to generate some nonsense based on a list of words. So I have prepared some files here. So for example, there is this words list. So this is just a list of most common English words, I think, which I found somewhere on the internet. And we would like to simply sample with the same probability. Each word has the same probability to be picked from this list. So we will generate some nonsense, but it will allow you to practice typing these most common words. Then there is another list, which is a weighted list of words. So if you take some text and calculate the number of times a particular word appears there, you can, well, put it down or write it down, and it's going to be its weight. So how often this word appears in the text. And then when you are randomly picking words from the list, you are actually taking its weight into account. So the more common the word is, the higher probability of us picking it from the list. The result will be the same, like nonsense, but yeah, it's good to know that this option exists. And finally, one of the methods that we're going to be adding today is just reading some lines from file. As for the next episode, we are going to explore text generation using Markov chains. So as an input, you will provide some text, a book or anything from which we can extract sentences, process sentences, see how words appear there, and yeah, pretty much construct some simple Markov chain which is going to generate some interesting text for us. It will still be nonsense, but it will be much better and much closer to the real text than what we're going to be doing with just randomly picking words from a list. I guess that's about it. So again, we can just jump into it and start introducing this enum named TextSource, which is going to tell us what kind of ways we can grab the text from, or we can get the text from. And I think we need to derive debug because our config where we're going to be adding this text source derives debug. So first of all, we'll have some static text. So these 3 lines that we are currently using, we will return in case configuration tells us that text source is static. And so we can comment here, hard-coded text, always the same. Then we will generate nonsense from a list of words. Generate nonsense, right? So as I said, we have these words, and we will just randomly pick them and generate some nonsense. We will pick something like 100 of words, and you can just practice typing these most common English words. Next step is generate nonsense from a list of weighted words. So as I explained, we have this weighted list, and the words that appear in some text more often will have a higher probability to be picked for our generated text. We can name it generate weighted nonsense, and finally grab lines from a file. So it will be a file string, where string will be some path to the file that we want to read from. So this text source will be coming from config. That's why we need to, the way we get text for our practice sessions. It's going to be just simply text source, not an option, it will always be defined. For now, we default it to text source static. I think we need to import that. All right, and now we can start using this config in our getText function. And we can drop this to do. Let's say match config text source. Let's fill the arms and move this OK right here. All right, so in case config text source tells us that the source should be static, which it is currently set to, then we should have the same result as before, right? So the same text as before, nothing new. But what we can do now is introduce some new functions that will return some new text for us. So the function generate nonsense, returning result string. So what do we need to do here? First of all, grab file contents from data words.txt. As I showed you, we have this file. I prepared it beforehand. Then we need to split the content by lines. Essentially, this is going to be words because there is a single word and a single line. And then randomly pick, let's say, 100 words from that list. Now, if we simply join these 100 words into a single line, our UI will show it as a single line. Like, we don't have any automatic breakdown into different lines based on width or anything. That might be a content for one of the future episodes. So for now, what we're going to do is split the list of picked 100 words into groups of 10 words, right? So we will create artificially some lines. Each line will have 10 words in it, and then just construct lines. So let's do exactly that. First of all, let's just throw in the to-do macro here so that it doesn't complain. All right, so how do we grab file contents? Contents is nothing but fs read to string. I think the path is predefined words.txt, right? And contents is now result string error. We want to extract the string from it. So we have contents. Next, we want to split the contents by lines. So which means we can tell that words is going to be a vector, contents, lines, right? Collect. And it works just because, as I said, our words file, words is a single word per line. So after doing that, running the lines, which is an iterator, we collect every single word into our vector. All right, so next thing is randomly pick 100 words. We need some library to achieve that. I think it's named rand. Right? It's 0.10. I think I used the one at 0.9 some time ago. Let's see whether I can still use it here. Not 9 by 10. I'll let it install everything. All right, so what we need to do is we need to initialize our RNG. Right, so what is RNG? A fast pre-initialized generator. All right. So that we can then ask this RNG to produce a list of selected words. How do we do that? We're saying words, sample, we need a reference, mute to our RNG, and amount, as I said, like 100 operator. So we need to probably say that it's going to be a vector, so we need to collect it. Alright, as you can see, it's actually a reference of those string references. So we need to do a copied call so that we simply copy the references instead of referencing the references. Now that we have selected words, we would like to split them into groups of 10. So we can say that lines is also like a vector. It's going to be selected words, and we can say chunks. Size is 10. Then we can map each chunk saying that, hey, join all the words in this chunk with space. Right? And we can collect that. And finally, we can return a result where we join the lines with new line. Then we format everything, and yeah, looks good, at least like compiles. So we can jump into our config, and for the default config, we can change static to generate nonsense. Let's run it. It builds rand, and as you can see, now we have some text, which really isn't a text, it's just a bunch of words, most common words, but you can practice with them successfully just to hone your typing skills. There is like no punctuation, no meaning, it's just most common words. You're typing them out. I think it works, right? So let's do the next one. Generate, we call it weighted nonsense. It should probably look similar to our generate nonsense thingy. First of all, we need to grab the contents, weighted. But the difference here is that weighted is actually the line contains the string, which also needs to be split by space. So we cannot simply copy and reuse anything from here. So let's see how can we do it. We probably need to do it this way. So let's create a vector of words. The type is unknown, vec new. We don't even need to say that it's a vec because it's clear from the new. Let's add to do macro. It doesn't know which type yet. Next, we can iterate over each line in contents lines. Right? So this line right now is actually a word, space, and a number. Its weight. So let's try to split it, which means that we want to say that line split by space and collect. Again, I think we need to tell it that it's going to be a vector. Then we can do an assert that parts length is actually 2, just to verify that the file, this words weighted, is, or it only contains lines where each word is followed by a number. Now that we have asserted the length of parts, parts 0 is our word and parts 1 is our weight, but it's still a string, which means that we need to try and parse it using probably just some unsigned u32 unsigned int, 32-bit int. And this actually returns result. We only interested in success case, so the weight now is our u32. And then we can simply say that, hey, push us this tuple, the word and its weight. And for that, I think we need to have words mutable. And now it knows its type, right? So reference to a string with its weight. Once we have processed the file, we now have these tuples. We can once again create our RNG, and then selected words, which is a vector. We are going to be using the sample weighted method. So again, reference to RNG, same amount, 100, but here it needs to have a function which, given an item from this vector, from this container, we need to provide how to extract weight from it, and in our case it's the second item of the tuple. The result is actually we need only success case, and then we need to only grab the word, and then we need to collect, right? Quite a huge line. Let's format it. So again, this is our list of words with its weights. Then we pick 100 using the second value from the tuple, which is the weight of the word. And this one returns a result, right here, result, index samples. So we are interested in success case only. That's why we have this question mark here. Once we have picked 100 items from this words vector, we have received a vector of tuples. Right? So it's still a vector of tuples, it's just there are only 100 or less elements, depends on how many items there are in the file. That's why we have the map here, where we only interested in the word itself, and then we collect into a new vector. I think the next thing that we do is the same as before. We once again group the selected words in chunks of 10, join them by space, and lines we join by new line character. Seems to compile just fine. So once again, jump to our config and try to set this generate weighted nonsense. Really, we shouldn't see that much of a difference. In case it doesn't fail with any assertion errors, it seems to be working as expected, right? We still get the same nonsense thingy. It's just the list is a bit different. I took it from different place, found it in different place, but it showcases the ability of us to pick the words based on some weight. So the probability of more common words is higher than the rarer words. So one more thing that we need to do is to be able to read lines from a file. So let's do just that. We have a path to our file, and we create new function, read lines from file, where we have some path right here. Path is a string. We can, I think it will be a problem, but let's see. So function, we have path. I would like to have it as a reference, result string, to do macro right here. Yeah, it's because config is a reference, and we are, yeah, we can reference. Still an error. Move out. It's because we have borrowed, we have reference, and here we're trying to move out the whole string right here. So instead of using reference, we can say that, hey, we're gonna be using ref string right here, and this coerces two string references quite nicely. All right, so that was like a Rust thingy. If you don't understand it, just you can ignore it for now. I mean, it doesn't really influence our main goal of writing our typing trainer. All right, so how do we read lines from file? Again, same contents, read to string, except now it's not a predefined one, but path, and we're only interested in success. Okay, so contents are there. What we need to know now, we need to grab the lines, which is going to be a vector. It's going to be contents lines collect. So now it's a vector of lines. First thing that we need to check is whether this vector is empty. So if line C is empty, and here you can either throw an error saying that you have supplied some empty file, or we can simply say return okay empty string. Like really, you don't have anything to practice on. You will instantly succeed. But this is edge case, and we're not really interested in that. I mean, we're not writing some production ready tool that is going out in disparate amount amongst like a million people. All right, so now that we know that lines are there, we need to know, what do we need to know? So we would like to pick some small amount of lines from the file. Let's say we pick just 5 lines, which means that max lines is lines length min 5. Right, so if we have 3 lines in the file, we'll pick 3. If it has 5 lines, it will be like 5, but if there are like 10, 100,000 lines in the file, we will still have a minimum just of 5 lines. Next, having all those lines, we need to know from which line we can actually start grabbing these lines. So if we have only 3, we always need to grab from the first one with index 0. But if there are 100, we can actually grab it from 0 up to, right, let me show you like in code. So like probably not start index, but maximum start index. And if, let's see, so if lines length is equal or and else. So if our file contains more lines than the max lines, we can then subtract these two values and in here. So let's assume just for the example's sake that our file has 100 lines, and based on this line of code, max lines is now 5. So we want to grab 5 consecutive lines, and the start index signifies from which line can we actually start grabbing the next 5 lines. So we can start it from 0, from 1, from first, from second, from third, from and so on line, but we cannot start grabbing it from like 97th line because there are less than 5 lines remaining. That's why we're saying that in case there are a lot of lines, we are limited. The upper limit is the number of lines, subtract the maximum lines that we can get. And in case there are like 2 why do we have it? Yeah, in case the number of lines is like will be always this, right? So I made some mistake here. I think that if we have only 2 lines, max lines will always be, yeah, we don't even need that. Because max lines cannot be bigger than line's length, because we have this minimum here. If line's length is less than 5, we pick the line's length itself, which means that max lines is length. And if line's length is bigger than 5, we are sticking to 5, and we know that line length is at least 5, so we can always subtract these two things, knowing that it will result in a value from 0 to up to anything like positive. Alright, that's a nice find. So the next thing that we need to do is we need to pick an index. So if we have 100 lines, we are picking 5 lines. The index we can start from can be 0, 1, 2, 3, 4, 5, etc. up to 95, right? So if we start from index 95, we can grab successfully 5 lines, which will essentially grab the last 5 lines from the file. So these are all the options, and we need to pick just one. So that's what we're gonna do. So let's start index. We need to check. What do we need to check? If max start index is greater than 0, we do something else is 0. So if we're told that we need to grab something from not from the first line, it means that we need to randomly select things. So let's bring in our RNG, rand RNG, and then we can say there's some random range. So random range, it picks a value in the given range. So we want to have it just a single value from this range, from 0 to 95. In this particular example, it will give us a single value, for example 2, right? Which means that starting from index 2, from third line in the file, grab me the next 5 lines. And once we have this start index, we can actually grab those lines. So selected lines is what? Our lines start index up to start index plus max lines. And yeah, we need to slice. All right, finally we simply return those selected lines, joining them back by new line. So I kind of feel that I didn't explain it way too well, but hopefully you understand. There's nothing really too complex. I mean, essentially we have a big file, a lot of lines, and we need to pick an index from which line we are selecting the next, let's say, 5 lines, right? We cannot start from one of the last lines because we won't have enough lines to grab. That's why we have this max start index. And then we're using just some helper which picks a value from the range. And this allows us to grab the lines from the index that we randomly selected up to, not included, this start index plus max lines, because we want to grab this particular number of lines from the file. Alright, so now we can check it, verify that it works, and I don't really have any file prepared, so let's do it just from main res. To have it as a string. Let's run it. Yeah, I didn't pick that. Good. Yeah, so loop let text. So we're kind of practicing to type out the code. But yeah, as you can see, if I rerun it, yeah, it picks different parts of my main file. There are of course some issues, as you saw. For example, the first line is empty, and in case you want to improve that, you can probably skip empty lines so that we don't ever pick the chunk from the file starting from new lines. That's an option for improvement. If you want to contribute such a PR to this project, please do. I welcome it. I will review it. I will add it to the final repository. But for now, for just our practice, or for our tiny project, I guess like this is enough. So really, that is everything I wanted to show you today. So we now have the ability to have these 4 different types of sourcing the text from. In the next episode, we'll be adding generate text using Markov chain. So it will be, let's say, something like Markov chain using string, where string will be a path to a file to learn from, or where we construct or pre-process all the data for the Markov chain. For now, this is marked as to do. And this should potentially produce a more nicely looking text with some sentences in it. Those sentences won't make too much sense, but you will see some punctuation, some capitalized starting words of the sentence, right? So it will just look a tiny bit better. And it's an actually very interesting project of its own to teach Markov chain based on some text to produce some output. And finally, we need an episode, right, where we introduce the clap library for the command line arguments, so that our config is not constructed by hand, but it will still have some defaults, and it will enable us to provide all these values via command line arguments. And in that episode, we might even introduce a bit more flags here to manipulate how we show the text. For example, we can limit each line by the width or number of words in the line, and so on. I'll have to think about that. It's not yet ready or prepared. But I guess, or I hope that you like this episode. Hope you like these kind of projects. If you do, please like the video, subscribe to my channel. It helps me a lot. And thank you very much. I'll see you again. Bye.